So code-wise, this is exceedingly simple. Up here, we're just defining our frequencies. So like the note C would be equal to 33 hertz. Down here, we're just defining all of our pins. So importantly, we're defining the pins that we want to trigger if we want to switch octaves. So to be octave 1, you would trigger pin A2, octave 2, A1, octave 3, A0. And then we're defining all of our note pins. So again, we were looking at C up there, 33 hertz. To trigger the note C, you would do digital input pin 2. And then down here, like I said, exceedingly simple. So this would just say, these three sections of code would say, if you trigger the octave 1 pin, then the octave equals 8. If you trigger the octave 2 pin, then the octave equals 16. If you trigger the octave 3 pin, then the octave equals 32. And then here for C, it says, while the pin that is responsible for C is being read as high, the tone, or generate a tone on the buzzer. So up here we defined the buzzer as an output for A4. So generate a tone on the output pin of A4, and the tone will be the note C, what we've defined it as, times the current octave. So if the note C is 33 hertz and the current octave is 8, because we've got it set to the lowest octave, then that'll be, I think, 164 hertz, or multiply it by 16 for octave 2, or 32 for octave 3. And it just does that for every single note. But wiring-wise, I'd say it's even simpler. What we've got is we've got our Arduino Nano, and then you saw the pad that I had my left thumb on in the video. That's just pulled to 5 volts with the pin from the Arduino Nano. And then each of the notes are attached to their appropriate digital input pins. So if this is note C, then it's attached to digital input 2. And then the note pads are tied to ground with a 1 million ohm resistor. And I will show you why that's necessary. If I can just sneak a multimeter in here. So I'm going to set it to read resistance. And then I'm going to put one needle on one thumb and one on the other. So we're reading around 500 kilo ohms. So effectively, my body acts as a resistor from one hand to the other. So if I if I always have one thumb on the 5 volt pad, and then I press a note pad with my other thumb, then I'm effectively bridging those thumbs, or bridging those pads, with a 500 kilo ohm resistor. And then you've essentially got a voltage divider. It's 500 kilo ohms would be the first resistor from 5 volts, and 1 mega ohm would be the second resistor to ground, which would bring you can calculate the law of voltage dividers. I just made that up. This pad would essentially be at, if this pad is at 5 volts, then this pad in the middle, the C pad, would be at 3.3 volts. And that's high enough for the Arduino Nano to read that as a digital input. And so the Arduino would register that as you playing the note C, and would output 33 hertz times the octave on the buzzer pin. So that would be your buzzer output. And that's your annoying ass buzzer tied to ground. Yeah, so super simple.